This is session 3. In session 3, we will discuss functions and modules. We need to understand one thing, there's no point reinventing the wheel. There are a lot of functions and libraries and code already written, and there's no point doing the same thing. So almost for every job you do, you will find some kind of functions to starting with. In this session, what we will understand is some functions, what functions are, and understand the concept of functions and modules. These are all the programs available for this program, this particular topic. Like, let me explain few programs, and then I'll explain the code along with the output in the presentation. These are the programs available for you, all right, which I'll be sharing the way I shared yesterday. So let's look at the first program, python3.py. See, this program is quite simple. First is Python bank, right? The bank which tells which binary will be used to execute or to parse this file. This line is comment. Okay. So whatever you write, that really does not matter what we write here. This is function we are defining, how we define the function. Like this is print me. This is a function I am defining, and this function is going to take one string type input. We can pass arguments, and that argument will be string type. This is called doc string. This is for, you can take it as a comment. This will not be printed. This is basically to explain what this function is going to do. The colon is mandatory, and then we are calling print function to print the value passed, which is here. This is placeholder, and we are printing that value, all right, and return. Now we are calling this print me function, and this is how we call it, print me, and we are passing this string. This string will go and replace this value, and this will be printed here. And this is another call. So if I execute this, this will print the first value because of this print me, and second because of this. So because 2 times the function is called. Advantage you can see from this small piece of code. One is, if you have same piece of code, few lines of code which you need to execute at multiple locations. In this particular example, there was a single line. Assume that there were 20 lines, and you have to call those 20 lines twice, so they become 40 lines. So this will actually make your program, number one, readable, number two, code reusability. That means you will write one piece of code and you will use it twice. For example, I'm calling this function twice here. So there are many examples which I'll explain through the presentation. This was just a quick demonstration so that you understand. Now let's get into the concept where I'll explain the other programs as well, because the screenshots are taken and the output is also taken. So session 3, functions and modules. What you will learn at the end of this session: definition of functions, defining functions, variable scope, global variables, function parameters, returning values, introduction to Python modules, and importing modules, the existing modules. Basic concept, but useful concept, because this is how slowly and steadily we are building Python. Understand that we are going to follow a different approach after a few basic lectures, and that approach will be production level approach, real life examples approach. We'll discuss some scenarios, we'll discuss some projects. As I said, there are going to be around 25 lectures, 20-25 lectures. So once the basics are clear, then we'll follow the project approach. We'll be working on some projects, we'll be working some real meaningful stuff, like developing a calculator, right, in Python. So yes, so we are going to work real meaningful work. We are going to do some real stuff in Python once we understand the basic language Python. All right, so that's why this session 3 is again another building block where we'll understand what all functions are and what are the modules. By definition, function is a block of organized reusable code that is used to perform a single related action. Organized reusable code means you write once and use it as many times as you want. Give it a name, call it by name, as simple as that. Every language have a concept of functions, even shell scripting have concept of functions. Functions provide better modularity for your application and a high degree of code reusing, that is reusability of the code. Python gives you many built-in functions like print, which you have been using, which you used on lecture 2 also, lecture 1 also. You can also create your own functions based on your need. These functions, when you create for yourself, are called user-defined functions. Every program, every programming language have functions. How do you define a function in Python? Simple rules to define a function in Python. Function block begin with the keyword def, followed by the name of the function and the parentheses where you define your function. All right. Any input parameters or argument. What are input parameters or argument? I'll give a very simple example. If I ask you to add two numbers, you will say what are the numbers? So those two numbers will be arguments. The function will take values or the operands on which is going to work. Parameters or arguments should be placed within these parentheses. You can also define parameters inside these parentheses. The first statement of a function can be optional statement, that is docstring. You notice that one line was there within double quotes, which was actually giving the meaning of the function, why we are creating that function, right? And the code block within every function starts with a colon, that is indented. If you notice, the rest of the code was indented like this, and we started with indented mode. The function def started from here, but rest of the code was indented. Because Python is very particular about indentation, and that's how it understands the block concept. The statement return expression exit a function, optionally passing back an expression to the caller. Like if I ask you to add two numbers, you will take two values from me and then you will return a value back to me. If I say 2 and 3, you'll answer okay 5. So this 5 is the return value. So I am calling that function and you are returning that value. The return statement with no argument is same as the return none. This is the syntax or grammatical way of creating functions. So you first write def, then function name, then parameters, then colon, and then indented definition of the function. This is the docstring I was referring to with double quotes, and this is function suite. The function suite means where you define your function statements. And the return. Optionally, you can specify expression. Square bracket means it is optional. By default, parameters have positional behavior, and you need to inform them in the same order that they are defined if you have more than one. So for example, def print me string. This print a pass string into this function. This is called docstring. Then print str and return. Please note that all these lines start at the same level, same indentation level. This should be inside D, but how many characters, that is not important. 2 character, 3 character, 4 character. Alright, but there has to be at the same level. I mean, you cannot write print statement starting from here. I mean, this return cannot start from here. If P is just, it should be below P. They are to be at exactly at the same level. We can call the function from another function directly from the Python prompt or directly from the Python prompt. And this is the example I demonstrated, python2.py. This is the same program. Defining the function def print me str docstring, that is comment, print str return, and now we are calling the function. This is call. I'm calling the function twice, print me, by passing this string within double quotes. So whatever I'm passing, this entire string is passed into this variable, and this variable or this object, the string object, is printed here. Print me, again second call to the same function. So this time this this is passed to this object and this is printed here. Python uses the term object rather than variable because they are immutable. Python 3, so we are calling this, and this is the output as we have seen. Pass by reference. Pass by reference is like passing the address. Like this is where the value 6 is stored, and this address starts at 110. So what you are passing, you don't pass the value 6, you pass the address 110. That's called reference. So when you pass this address, inside the function, you have this 110 address passed. So inside the function, if you make changes, that will be reflected here because ultimately you are passing the address. That's called reference. Alright. All parameters, arguments in Python are passed by reference. It means that if you change what parameter refer to within a function, the changes are also reflected back in the calling function. Take an example. Change me, we are passing a list. By default, this is the behavior. They are passed by reference. This change a passed list into the function. This is docstring. MyList.append. MyList is the reference, the object name, which is holding the value, and we are calling append function to add additional value, additional element to the list 1, 2, 3, 4. And here I'm trying to print the value inside the function MyList. So whatever list was passed, we added these 4 values to the end of the list and we printed the entire list. Now calling change me function MyList, I'm creating a list with this name 10, 20, 30, and I'm passing this value to change me function, which is defined here. The value outside the function will be MyList. So what do you expect? It will be same what is inside the function and what is outside the function. Let's see the output. When you run this program, value inside the function 10, 20, 30, you pass this list, you appended 1, 2, 3, 4. So entire list is printed here, right? When you are back to your program, because it was passed by reference, because the address was passed to it, therefore you are getting the same value outside the function as well. No difference. This is just to prove that by default, all the values are passed by reference, by address, not by value. So in the previous example, we are maintaining reference of the past object and appending value in the same object. And this is the output of the program. Another example to understand. Argument is being passed by reference and the reference is being overwritten inside the function. Change me, MyList. MyList is 1, 2, 3, 4. I'm assigning equal sign. So this would assign new reference in MyList. It will overwrite. And the values inside the function MyList, so it will display all 1, 2, 3, 4, right? Because we are assigning it, correct? And we are returning from the function. And we are creating a new list here, and this list we are passing to the function. So what will happen? These values will be overwritten, and this will be overwritten into the address, and new list will be printed, whether we are using this print statement or in this print statement. You'll get the same list. This is another proof. If the argument is passed by reference, the reference is being overwritten inside the function. So a reference is being written inside the function. this will print value inside the function 1 2 3 4. My list 10 20 30, change me my list. We are calling this and we are assigning the value, and when you print it, value outside the function, it is printing. This is not called by call by reference. This is not done. This is not correct, because what am I getting outside the function? I'm getting the value which were originally available, right? Well, I'm getting the same value here, what I passed, So value inside the function is changed. That means this variable is not global. This is local. Point to be noted. So here comes the question of local and global variable, and that is the reason it is mentioned here. The parameter mylist is local to the function change me, and changing mylist within the function does not affect mylist, because had it been global, it would have changed. So when you are using this mylist equal to 1 2 3 4, this is local to the function. And outside, so this mylist and this mylist, these are two different variables. One is inside the function, one is outside the function. And that is the reason outside the value remains what we assigned here. Though whatever we are passing, that is overwritten and the value is printed here, the changed value is printed here. You can call a function by using following types of formal argument: required arguments, keyword arguments, default arguments, and variable length arguments. Means different ways of passing value to functions: required, keyword, default, variable length. One by one. Required arguments. The argument passed to a function in the correct position order are called required arguments. That means you pass in exactly same order. Here the number of argument in the function call should match exactly with the function definition. Like in this case, we are defining one argument we are giving, right? So while calling this function, we must pass one argument here, and we are not passing in this case. So when we execute this code, it will throw an error. This is the error what I was missing. Type error. Print me missing one required positional argument. You got my point? Because we specify one argument here. This is the actual message. Keyword argument. In this case, when you use keyword arguments, the caller identifies the arguments by parameter name. Meaning is clear, you specify the name, you give the name. This allows to skip argument or place them out of order. You can also make keyword call to the print me function. Let's take an example. Def print me str. Same function. Function remains the same. But here we are specifying the keyword str with the value. That means we are using the keyword with its value, and therefore if we have multiple arguments in different order, you can specify each argument in whatever order you want, and you specify the value of the argument. So we are actually giving the name of the argument and the value of the argument. The advantage is that you can have multiple arguments and you can specify the value in whatever order you want. When the above code is executed, it will produce this output, my string, because we are passing my string and this is printed. Another example is more clear picture, because this time I'm using two variables, two parameters, name and age. Print name, print age. So printing the name and age, and I'm passing the value in different order. Like here, age is coming at second argument, but I'm passing it as first argument. So age 50, name Sangwan. So Sangwan will go to name, 50 will go to age. So you'll get name Sangwan, age 50. That is the point. That the keyword argument gives you freedom, that you can put argument in any order, provided you are giving the key followed by the value. All right, you are giving the complete details. So order does not matter. This is what the point is actually. Default arguments. Sometimes you may wish to specify a default value in case the value is not passed. For example, age equal to 35. In case you don't want to pass the value of age, the age will be taken as 35, else whatever value you will pass, that will be considered. So I'm passing age 50, name Sangwan. So in first example, name Sangwan, age 50 will be printed. But next time I'm calling the same function without age, only passing Yao. So what will be printed with Yao? 35. Age 35, name Yao. That is default argument. Variable length argument are also very important, because when you don't know what is going to be the size of the argument, then you use a C language like pointers for variable length argument. You may need to process a function for more arguments than you specified while defining the function. These arguments are called variable length arguments, and they are not named in the function definition, unlike required and default arguments, where we need to mention that, where we need to specify that. General syntax for function like with non-keyword variable argument is function name, formal argument, after that you put this star variable length argument tuple, and tuple means they are in the form of key value pair. So this is docstring, function suite, return expression, and asterisk is placed before the variable name that will hold the values of. Yeah, tuple is read only, because we are passing arguments are always read only. Non-keyword variable arguments. This tuple remains empty if no additional argument are specified during the function call. Look at some examples. Print info argument 1 and variable tuple. The output is first argument 1 is printed, and for where in where tuple we are printing all the variables. This where, you give any name to it, donkey, horse, monkey, but then it is going to be a placeholder for every element in the tuple one by one, and that's why we are using loop. We will discuss this control structures, not discussed so far. Right now you take it as all the elements will be processed one by one. Example will clear it. Print info 10. So only one argument is passed, that will be replaced here in the argument 1. Therefore you will get the output 10. Second time you are passing three values, 70, 60, 50. 70 will go to argument 1, but 60 and 50 will go to where tuple. So the where, when it is executed, this where, first time it will take value 60 and will print this statement. Next time it will take value 50 and will print this statement. That's why you will get all the value one by one, 70, 60, 50 printed. Scope of variables, local and global, as I discussed earlier also. All variable in a program may not be accessible at all locations in that program. This actually depends on where you have declared a variable. The scope of a variable determines the portion of the program where you can actually access a particular identifier. And there are two basic scopes, global and local. So global versus local variables. Variables that are defined inside a function body have a local scope, and those defined outside have a global scope. This means that local variables can be accessed only inside the function in which they are declared, whereas global variables can be accessed throughout the program body by all functions. When you call a function, the variable declared inside it are brought into scope. We'll understand with example. For example, total is 0. This is outside any function. So this is global variable. You can use it inside the function also and outside the function also. Available everywhere. Now we are defining a function. Function is sum. We are passing two values, argument 1 and argument 2. And we are calculating total, argument 1 plus argument 2. This total is local. And print inside the function, the local total will be whatever variable. For example, you passed 5 and 7. So this 12 will be the value here. And it will return the total value 12. Now you can call the function sum 20 and 10. So what will be printed here because of this statement? 30. So the value of 20 total is 30 inside the function. Outside it is 0 and it will still be 0. If you try this, outside the function global total is still what you passed, which was there, that is 0. And that's why you see inside the function local total is 30, outside the function the value of total is 0. Once again, sum 10 20, 10 will go to argument 1, 20 will go to argument 2. So total local variable inside the function 10 plus 20 30. So you are printing that value 30 here. So when you call this function sum, it will print this statement with value 30, which is coming out here. That is outside to prove this, that this variable total is global and it is outside the function. And this will be printed because of this statement. So this statement is printed here. Outside function global total, outside function global total is whatever the value of total is, which is this one. This total is different. This total is assigned a different memory area. And this total inside is declared in a separate memory area. Any variable declared outside is global. The return statement. Statement return followed by expression exits a function, optionally passing back an expression to the caller. The return statement with no argument is same as the return none. Now look at the example. Function definition, defining sum, argument 1, argument 2, add both parameters and then return them. Total argument 1 plus argument 2, inside the function you are displaying it and then you are returning back. When you are returning back, the advantage is you can assign this function to another variable like this. Total equals to sum of 10 and 20. So what is happening here? This 10 is going to argument 1, 20 is going to argument 2, and this is being calculated here, and this value is returned. So this total is coming here after the calculation is done. So this is local variable, this is global variable. This total, whatever value is inside this total will be assigned to this total. Now outside the function you will get the value to 30. This is example. Total is 0. This is global variable. Defining the sum, argument 1, argument 2. Total is argument 1 plus argument 2. Inside the function trying to print the value, return the value 20. Return the value whatever is stored inside the total, which is like if you are passing 10 and 20, which will be 30. Python modules. Python modules allow you to logically organize your code, like you have chapters in a book. Grouping related code makes the code easier to understand and use. And that's the purpose of module. For example, all mathematics functions, I would like to group them together, put into a library or a module. All string related functions, I would like to put them together. This is called module. In Python, ls, for example, Python module is a Python object with arbitrarily named attributes that you can bind and reference. Is a file consisting of Python code. You can define functions, classes and variables inside a module. Python code. For a module, let's say the name you want to specify as a name normally resides in the file with the name aname.py. Here's an example of simple module support.py. You put this kind of a simple definition, def, print function, and the parameters, print hello, and a return. So you simply write your functions inside this, and that will be a module. Point is, we write modules to place multiple similar kind of functions, same type of functions. And if you want to use the functions which are defined inside a module, which are declared inside a module, you need to import them. And that is the reusability and organization of code. What you do, you normally place the same type of code into a file, and then you import it wherever you want to use. Imagine you are writing trigonometric functions in a file called math trigonometry, and then you want to use any of the trigonometric function. Then you need to import this module. And this is what I was talking about. There are a lot of code already written. Alright. And almost for every purpose you will find a code. You can use any Python source file as a module by executing an import statement in some other Python source file. For example, import module 1, module 2, module 3, and so on, separated by comma. When the interpreter encounters an import statement, it imports the module if it is present in the search path. This is important question now. The search path. Search path is identified by some variables. Search path is a list of directories that the interpreter searches before importing a module. To import the module support.py, you will specify import support. You don't specify .py, you specify just the name. And then you call the function support.print function, and you are passing the value. Now what you have done, the function is declared in support.py, and you are calling that function in another program, another file. You got my point? The module is loaded only once, regardless of number of times it is imported, and you can call it as many times as you want now. From import statement with star. Star means all functions, import all functions. It is also possible to import all the names from a module into the current namespace by using from module name import star. This provides an easy way to import all the items from a module into the current namespace. However, this statement should be avoided. Locating modules. When you import a module, the Python interpreter searches for the module in this sequence: the current directory, the shell variable, that is Python path. All fails, then Python will check the default path. How to check what is the default path? How to check what all directories are included in the path? The module search path is stored into a system module with the name sys as the sys.path variable. The sys.path variable contains the current directory, Python path, and installation dependent default. How you execute? Simply you can try from the Python prompt, import sys and then sys.path. This is what I tried. Look at this, python3, and then I imported sys, and then I try to get the value of sys.path, and these are the locations where your module can be. The current directory is also included, your home directory is also included. So anywhere you can place your module, any of these directory, in any of these directory you can place your module. The Python path variable. The Python path is an environment variable consisting of a list of directories. The syntax of Python path is same as that of the shell variable path, which you use echo $path, right? Similar. This is a typical Python path from Unix system like set Python path, userlib64, Python 3.6, where you feel your modules are. Namespace and scoping. Variables are names that map to objects. Namespace is a dictionary of variable names, that is keys, and their corresponding objects, that is values. A Python statement can access variables in a local namespace and in the global namespace. If a local and global variable have the same name, the local variable shadows the global variable. You recollect the total outside the function and total inside the function. Local was printed, not the global. Each function had its own local namespace. The class method follow the same scoping rule as ordinary functions. Python makes educated guesses on whether variables are local or global. It assumes that any variable assigned a value in a function is local. Therefore, in order to assign a value to a global variable within a function, you must first use the global statement. For example, global variable name tells the Python that var name is a global variable rather than local. Python stops searching the local namespace for the variable if you declare this way. Example to understand. Here we define a variable money in global namespace. Within the function money, we assign money as a value. Therefore, Python assumes money as a local variable. However, we access the value of the local variable money before setting it. So, unbound local error will be the result. This is what I'm trying first time. Python 3 session 3 python12.py. This is my program. Money is 2000. Definition add money. Global money. These are comments. So money equal to money plus 1. I have not declared it. I have not passed it. So when you try this, you will get the error. And this is the unbound error. You see here. Add money. Line 6. Unbound local error. Local variable money reference before assignment. Uncommenting the global statement. If you remove this comment, then it will work. After you uncomment, if you try, you will get right value. And you'll get 2000 and 2000. First you will get 2000 and then you will get 2000 plus 1. That is 2001. Because by default here you are getting the value 2000 and you are adding 1 to it. That will make it 2001. Directory function. The dir function is built-in function that return a sorted list of strings containing the names defined by a module. The list contains the name of all the modules, variables, and functions that are defined in a module. For example, import math. You are importing mathematics library, mathematics module. Content equal to dir math, and you print the content. So you'll get all the functions which are declared in mathematics. I mean math library. GCD, gamma, fsum, fmod, floor, log, log10, log2, mod f, pi. See all the mathematical functions you can see here. And they are available in maths library, math module. In the output, the special string variable __ name is the module name. And __ file is the file name from which modules are loaded. Global and local functions. The global and local functions can be used to return the names global and local namespaces depending on location from where they are called. If local is called from within a function, it will return all the names that can be accessed locally from that function. If global is called from within a function, it will return all the names that can be accessed by globally from that function. And the return type of both these functions is a dictionary, that is key value pair. Therefore, names can be extracted using the keys function. The reload function. The module is imported into a script. The code in the top level portion of a module is executed only once. Therefore, if you want to re-execute the top level code in a module, you can use a reload function. The reload function imports a previously imported module again, like reload module name. The module name is the name of the module you want to reload and not the string containing the module name. For example, reload hello. Will reload the hello module. Frequently used modules, important list will have information about Python itself. OS, operating system functions. os.path, portable path name tools. shutil, utilities for copying files and directory trees. CMP, utilities for comparing files and directories. Globe, files to find files matching the wildcard pattern. Regular expression RE, time for time and date finding. Date time, fast implementation of date and time handling. Doc test and unit test, module that facilitate unit testing. Remember that we are going to get inside the detail of each one of them. We have to do a lot of examples, and this is where you will understand that yes, we are going to deep in depth of this Python. This is the first time I think you might be feeling that it was a little complex thing which we discussed today, because the module and functions is altogether new. It is not that basic thing. The OS module provides dozens of functions. So OS module provides dozens of functions for interacting with the operating system, like import OS, dir OS, help OS. Alright. Some of OS module functions: os.get cwd, that is current working directory. OS change directory, you want to switch to a different directory. OS system mkdir, you want to create a directory. Introduction to language modules. Modules are searched in the following places. First, current working directory for interactive session. The directory of the top level script file, that is for the script files, and the directory defined by Python path, and standard library directories. And this is how we use it in the Python prompt itself. Interactive session, import sys, dir sys, or print sys.path, import numpy. These are all modules. We'll go through one by one. For example, next session is maths, so we'll discuss only one module in the next session, and that will be math module. We are going to spend 1 hour nearly only on maths module. A package is a hierarchical directory file structure. A package is a hierarchical file directory structure that defines a single Python application environment that consists of modules and sub-packages and sub-packages. Consider a pots.py available in Python directory. The file has these lines of code. Define pots, that is a function. Print I am pots phone. Similar way, we have another two files having different function with the same name. Like one is inside pots, inside phone, that is ISDN. This also have this same function. Another is G3. This also have the same function. So now create one more, init underscore underscore int underscore underscore dot py in the phone directory. Alright. That is phone slash underscore underscore init underscore underscore dot py. These values. To make all your functions available, when you have imported phone, you need to put explicit import statement in this file, and this is what you are putting here. Pots from ISDN import ISDN, from G3 import G3, and now you can use them. Import phone, phone pots, phone ISDN, and phone G3, and you are calling the appropriate function. When above code is executed, it will produce this kind of output. I am pots phone, I am 3G phone, and I am ISDN phone, corresponding to the functions which are declared in these files. In this example, we have taken an example of a single function in each file, but you can keep multiple functions in your files. You can also define different Python classes in those files, and then you can create your packages out of those classes. Going to be much more interesting after the session. Thank you very much.